All right, so I think we're ready to get started here. So welcome everyone, and thank you for joining us for today's Data and Dialogue session. My name is Tess Conway, and I'm the program coordinator for the Urban Curricular Programs. This Data and Dialogue series was developed by Chicago Studies, a program of the college that offers curricular and co-curricular opportunities for the college community to study, engage with, and positively impact the diverse communities of our world-class city. The Data and Dialogue series offers participants a behind-the-scenes look at a Chicago-relevant dataset, archive, or other resource for research about the city. This session is co-sponsored by the Program on the Global Environment, which fosters undergraduate study of the complex intersections of urbanism, environment, and society. The program is home to the Environmental and Urban Studies BA major and minor program, which motivates a deeper theoretical understanding of urbanism and nature, as well as practical strength in addressing urban and environmental challenges and opportunities for sustainable development. This Data and Dialogue session will introduce participants to the Energy Star Data Portal, a program run by the U.S. Environmental Protection Agency and U.S. Department of Energy that promotes energy efficiency. The program provides information on the energy consumption of products and devices using different standardized methods. Today's session will be hosted by James Novak. James is the data analyst for the University of Chicago's Facility Services beginning in September 2019. Since then, James has been involved with multiple projects within facilities, services campus planning and sustainability, and assisted with multiple efforts within the university, such as the Mansueto Institute for Urban Innovation's Environmental Frontiers, as well as the University of Chicago's Greenhouse Gas Emissions Inventory, data analyses, visualization, and reporting. James came to the University of Chicago from DePaul University, where he served as a primary analyst for the laboratory of the Psychology Department's Director of Undergraduate Studies, as well as pursuing his education in neuroscience and psychology, with an emphasis on cognitive theory. James's area of expertise lie within data visualization and integration, statistical analysis, and certain areas of data science. Welcome, James.
Hello, everybody. As you guys probably already know, my name is James Novak. I am the data analyst for UChicago Facility Services, and I would like to thank you all for letting me be here and speak to you all about something that I'm really passionate about, which is data and numbers and other things that make people want to go to bed, except for me, because I'm here probably about to just speak straight nerd to you all for a good, hour. So I hope you're ready for this. So let me pull up and share my screen and we will get ready. So I always like to go, especially when I talk about data, I like to go from process to end result. And for a lot of data scientists and data analysts, that's something that we always think about, is because the key to being an effective analyst is thinking in process, because we usually follow the scientific method. So I'd like to present to you all my Data and Dialogue series with Energy Star benchmarking. So first, I will give you our little introduction, which we just went through. Through data, which has a little bit of some subcategories, into the meat of our bones today, which will be the Energy Star benchmarking and the portfolio manager data set. And then from then on, I will move on for questions facilitated by Tess. So first off, I'd like to start out with data: where, what, when, why, and how. And I like to do this because we like to think of data as something that we use to create a result, but really, in my head, data is just the beginning of something with so many other little parts into it, because in a sense, data is multimodal, it's multifaceted, and sometimes it's a mystery, because there will be times where I'll have a data set in front of me and I will know absolutely nothing about what it is, and I am told to bring meaning to this data. And, every analyst, how some of us have backgrounds in neuroscience like me, and some of us have backgrounds in some other wonderful fields like the social sciences, and some people even went and got a computer science degree and started doing data. So there really is no right and or wrong way to start with your process, but your theory of mind will kind of change as you go down the road. So on top of that, data has so many different applications that, aren't always on a computer. People can use data to make visualizations on art, like, the pyramids of Giza is one of the examples, is that they use the amount of weight of sand and mud that were in turn used with calculations to be some of the most precise sculptures in the world. So data isn't necessarily something that we just use for calculations or looking at. Data is everywhere around us, and there's so many different applications for something that I love so much. So next slide. So the first thing I'd like to do when I get data in front of me is I want to see how the data looks. And that doesn't necessarily mean, how big are the numbers or how big do, the points go, how many rows, how many lines. There are so many things that you can think about data is that you have to think about what it is and what it is not. And that is always something that you see when you look at data for the first time. So it can, like I said, it could be numbers. And in our case today, it's going to be looking at commodities and certain calculations, or sometimes even how long did it take for one event to start and one event to end. It could even be a color. So there's so many things that we can call data, which really I think is one of the most beautiful things about it. But my first look usually does tend to be that raw skim of the data where we can, where did I get this data from? Who gave it to me? Was there any file explaining the data for me, which sometimes I don't even get. Sometimes I have to go in blind. Or any other points of interest that I, really can bring meaning to. But 100%, I will attempt to visualize this data in some way, shape, or form. And this is, in my theory of mind, a little bit different from what a primary business analyst would do, which is also part of my job. But I, and my background, would definitely start looking at what the data looks like statistically, so I can get a, in my mind, 3D representation of how this data is going to go out down the process. And we do this in the social sciences, which this is just something I pulled off of one of my favorite stats websites, Kaggle. So we would look at data in, is it normal? Which means, does the data fall halfway above the average and halfway below? Because if it doesn't, then there are certain other actions I have to follow suit after, because there are so many rules to data based on your analysis. So if you look over on our bottom right here, this little bell curve, we love to see this. And we also want to see it again in a histogram result, but also most importantly, this normal QQ plot will tell us, does our data follow a normal distribution? And you can see that the line that is projected, all of these little circles are so close together because they fall so close to the average, except for these little outliers. But also we want to make sure that our data is something that is very mixed. And we call that, we call that homogeneity. And we want that to have a pretty normal amount of variance in our data, so nothing falls so close to the average. Because if it was so close to the average, then we'd have some problem with the variance at the end. And that again would have to give us another way about how we go with our process after that. So now I go to the second part is, okay, so where did I get that from? Where did I have to understand that, there are these certain processes and, basically math that we have to follow when it comes to visualizing data and looking at data, because point to process we have to follow. And this is where I bring in the James of everything, where I like to bring in memes that kind of help us understand this, which is, data scientists and analysts, we're all obsessed with machine learning and neural networks and all these artificial intelligence. And that's really bringing the forefront of data to fruition, because 10 years ago, we were looking at repeating statistics over and over to validate. But now we have programs and algorithms that have been written to do that for us. But the problem is that now it's really being ignored that it's all just statistics underneath it. And AI and machine learning is really just statistics. And again, next point of the process is, why do I ask us to go back and think about fifth grade algebra? I'm not going to use this every day. Is this y equals mx plus b really going to have any type of theory of mind into what I'm going to be doing when it comes to data? Yes. Yes, I use this equation every day. 98% of the time, I look at this equation and I point of myself as getting this as a tattoo one day because of how much it brings meaning to me, is that this equation is something that you will probably be shown in fifth grade. And now this equation is basically the foundation of data analytics. And it's used in so many different types of analysis that are as simple as projecting a line, or as simple as creating many lines that can predict so many different outcomes. So, you know, I wish I could go back and thank my fifth grade teacher because, you know, this is something that I really do want to bring into importance, is that, you know, something starts from somewhere, but at the end it can blossom and become something else. So now we have these programs that are generating outcomes and needs-based resources, but they really all come from that one basic formula of change in X is going to equal change in Y, except for a bunch of other variations, which are what these are, but that's not important for right now. So again, now that we have looked at our data and we have seen in our heads what it looks like and how the data set can be constructed from then on, you know, data analysts like me, we come in and we take those visualization and we do what is called cleaning the data to make it look presentable and making sure that it is all in one straight line in a set that can be presented to you and used for visualizations and whatever needs be. So we like to call that, you know, creating a clean data set, but then at the same time, allowing us to have high integrity for our data, meaning that we believe that this data set is valid and usable in its straight form for any type of analysis, pretty much, with some minor tweaks that we will get to. So now that brings us to the data set itself. So we've gone through all the process. So now we're going to go to purpose. So today I was asked to bring and speak to you a little bit about, you know, Energy Star benchmarking here in the city of Chicago. So any commercial, institutional, residential building over 50,000 square feet within the city of Chicago proper is required by our City of Chicago benchmarking ordinance to submit our data on that building, such as commodity usage like water, steam, electricity, natural gas, and report that to the government, which is Energy Star. And then in turn, they publish that data, free source for anyone to look at as a terms to see where all of our buildings lie in energy efficiency between each other. So we're going to go and look at those. But first, I want to get into that whole part of process again, because there are other lists of qualifications that we have to consider according to Energy Star when it comes to this. So they lie this out. And this is something that what we would call a list of assumptions to a data set. So first, before submitting your data, all right, got to do this again. When we go to our data and our data set, it starts from collection. So we collect our data and there are rules for submitting this data. So is it, you know, going to be compliant for that year? So is it a commercial, institutional, or residential building over 50,000 square feet? You are required to give this data over to the government. And then on top of that, there has to be someone else who can facilitate this. And then it goes through a portal, which we will get into later. And all of these other rules and down to the building use type and the square footage, everything has to be given in a certain way so we know that it can be validated and given to us. So then it ends with reporting to the city. There's always a deadline. And then on top of that, someone's always there to help, which is usually somebody like me. So now that we have this, let us get back to our PowerPoint, which wonderfully decided to crash on me. So give me 1 second. And we are back in business. So right now, I would like to introduce you to the portal that we are so grateful for living in the city of Chicago, because there are other cities out there that are so close to holding their data. And sometimes, and most times actually, you can submit something called a FOIA request, which is the Freedom of Information Act, which most big time institutions and cities are required to comply with, where you will submit a report asking for your intended use of the data that you would like to ask from them and all of those other things. And they go, okay, thank you for the application. And 98% of the time, if it is compliant with the rules of the Freedom of Information Act, you will receive your data. Well, Chicago has our own data portal on not just, the Energy Star data, but so many other things, down to population density, down to literally pipelines underneath the city of where water goes from one place to another. So it's really cool. And that is just a level of granularity that I love that Chicago does. But first, let me speak to you about how we are going to download this data. So we go to the City of Chicago Office of the Mayor, and then you can go to I want to, and then find it, and then there is a whole other file and down there, or you could just simply go to Google and search City of Chicago Data Portal, and there are plenty of other folders through there. But we can go through here and go to the most recently reported data, which is for the year of 2019, reported in the past year of 2020. Wait for it to load. And then up here, you can look at more of the data's explanations and why the data was collected, when it was published,
Hey, James,
and who owns it.
Your PowerPoint still. All right. If your link didn't click.
Are we here? Can you hear me?
Yeah. Mm-hmm.
All right. I will go back to that. Sorry about that, everybody. Can we see it now?
Yes. Mm-hmm.
All right. So essentially, there is a portal that we talked about, and you can see by going to the Office of the Mayor, supporting info, energy benchmarking, and then it'll bring you to this page where we can click on the most recently published data. It'll bring us to this page, giving us background about the data, when it was updated, when is it provided by, when it was published exactly, how many people have looked at it, how many people have downloaded it, and on top of that, who owns the data, which is something that's very important because all of this data, while publicly available, sometimes is not used for public use, meaning that you might have to give a little statement saying on what you intend to do with your data, which is something that I find all the time in my position. But for now, you can just go to export, and then I prefer CSV format, but you can always go to a PDF format as well, or Excel. Really, it depends on what you're going to be using the data with. CSV, 98% of the time will be something that you'll pull. Go to CSV and it'll go down and you will be given the data in CSV format, which I will bring you to now, which is here. So as you can see, this is the most recent data provided by the City of Chicago for the Energy Star Portfolio Manager Initiative and Chicago Benchmark Ordinance. So as you can see, we have our headers here, and I always will start to filter. So this data is very organized and clean. I always like to adjust the columns so it's a little bit more readable, but you can see here that it was reported in 2019. Always look in 98% of the time again, the first row is always going to be the qualifier or identifier as to everything underneath it. So we look at the data year, the ID, which is just a unique identifier for that row of data. The property name, its reporting status, which if it was reported in the year before, it might be submitted, but then for this year, it was not submitted. The building's address, the zip code, the energy rating, which we will get back to in a second. Is it exempt from the Chicago energy rating? And this is the cool part, is that everything that the University of Chicago is required to give to the city, we wonderfully get to get some feedback on it, which is something that I like to look at and that we always look in here and talk with the Office of Sustainability is energy use intensity, which is shortened as EUI, which depending on these two, there is a strict difference, which as I believe the site EUI is only the energy use intensity for what you are buying. And what I mean by that is like you're buying water, you're buying usage of natural gas, you're buying steam. Whereas source is including everything that also it takes to get that product to you. So there is a very strict definition between site and source EUI. And EUI is just taking those commodities like natural gas, steam, water, and all those, and they take the gross square footage and you divide it by that, and we are given a metric. So the higher the EUI, the more energy is being used per square foot here in the city. So there is a little bit of a caveat to this as well, because as we know that there are certain things that always can be done when we explore data even further, which to my understanding, and when I first looked at this data set, I had to do a little bit of sleuthing underneath to understand, which was certain groups of buildings, depending on their usage type, like senior care community or a museum or multifamily housing, certain buildings like these have a higher EUI on average than other types. So when we go and we benchmark these and we look at, is one performing better than the other, it's unfair to take the big picture and look at, which building is using the most energy per square foot rather than the least. We tend to do that within groups because here at the University of Chicago, we know that a library isn't going to necessarily use as much energy as a lab building is going to. And that, using some deductive reasoning and understanding, is because we might have some really high-powered machines in a lab that require more water or require more energy, whereas a library would. So that brings me to a point that not every metric that will always be produced is necessarily perfect, but we don't also want a perfect metric every time, because that just not makes sense. We don't strive for perfection in data, we strive for efficiency and efficacy, because we want to bring point A to point B, creating that story of explanation to uncover the mystery underneath your data. It's not something like, all right, this is the metric, that's it. No, we don't do that. Because if I were to go here and take these numbers and create a visualization, it might not be appropriate to show the highest to the lowest because it's just going to be one sliding scale. And we know that. But if we can take another layer of granularity, like building type, and show the highest to lowest between types, then there's more to it. There's more what I would call meat to the analysis. Because analysis isn't always something that we see by a calculation. Analysis can also be done visually using a visualization. So I think it's cool that in data that there's so many different things that we can look at. And every year we can even compare between years because there's so many years that have been collected per the city of Chicago. And that's what I think is really cool, is that data is something that really has layers, and there's layers between meaning, and it's just so much boom in your head, and you just sit there and love what you do. But the cool thing is in the city of Chicago, we have it here by zip code. We have it by the community area, which for our purpose, I will look at Hyde Park, where most of our buildings reside. And here we are. We can go to the property name, and we can see here the Mansueto Library for 2019. So let's take a little bit of a scoot over. Gonna click here for organization and move over so you guys can see. We know that the Mansueto is a library. It's the giant Sphinx-looking egg robot library that I love so much. And for that year, the gross square footage was reported as 64,028. It was built in 1975. Is that true? That might be incorrect, but the Mansueto Library, I'm pretty sure, is pretty new. And number of buildings on it, there's only one Mansueto Library. Its water usage, not reported, but its electricity usage was reported. Its natural gas use was reported. Its steam usage, there is no data. Chilled water, not reported, but the site EUI was. So there is a high, or, we can see there is a 113 kilobtu per square foot in the energy use intensity for the site EUI for the Mansueto Library. Now let's go take a look at another big building here, which is going to be Jones Laboratory. Like I said earlier, we know that our laboratories use a little bit more energy than a library would. So we can see that the gross square footage is above 50,000. And that for that year, its electricity use was large. Natural gas usage was not reported. Its district steam usage was reported. And then the chilled water was reported. And we can see that the site EUI is almost 3 times that of Mansueto Library. So, again, when we look at our data, we have to understand that it is sometimes unfair to compare things certain ways, is that we need to understand that there are certain rules that you'll have to undergo when you give your analysis, as in comparing within groups or between groups. It all depends on your brain and its ability to bring that meaning to your forefront. So that's what I really like, is that, we're so many different opportunities here. But then that also gives us the opportunity to look. So maybe it's not just UChicago. We're Chicago. There's so many of us here. Let's take a look at all of Chicago and then look at other laboratories. So let me move over to our property type, and we will filter by laboratory. So one on the near north side, let's look at that. So that is on 303 East Superior Street, which is just known as 8846. So we know that they reported their square footage. And on top of that, the electricity, the natural gas, and other commodities. And its EUI is still very high. So when you go for analysis, you might start to notice some trends. And don't be quick to call out trends when you see them immediately, because there's always a way that you can go underneath and explain those trends. Never jump at analysis right off the gun, oh, so these 2 labs have huge, huge EUIs. That might just be for labs. You have to go back and understand that there's other things at play here. So, and then on top of all of that, the cool thing is that Energy Star will also calculate the total emissions. And then on top of that, the location, the latitude. So if you wanted to make a map with this data, you could, using a GIS or even something that I use a lot, Tableau. But the thing is the idea of benchmarking, which the Energy Star initiative does wonderfully. If I can get it to display, please hold. I'm gonna go back and unfilter. And you can see that it is a scale from 100 to usually 0. But just because there isn't a 0 there doesn't mean that it's not it's a zero. It's just the data was not reported. There's a very swift difference. But what we can do is from the data set is sort largest to smallest and see that we have the scoring going from, on an integer basis, from 100 down to, keep going and going and going. We're just going to scroll faster here. So you can see that Energy Star benchmarks each building based on all the metrics that they have created for this and gives it a score. So it knows that the buildings that are scoring higher have a better economic or energy impact than buildings that benchmark lower. So I think that's really cool, is that from start to finish, that there was so much process that goes down in just this one metric that was created. But the cool thing is that there's other metrics underneath it. So it starts to really bring me to my final point, which is that it is a cumulative effort for data to be brought together. It is not something that is so, 1 point, 2 point, 3 point. It is a 1 to 2. Did 2 work out? Nope, back to 1. And it's repeatable. It is a replicatable structure because this itself is art and science. So I think that's the most beautiful thing, is that I get to sit here every day and look at things like this, but know and appreciate that art can be created from science, but at the same time, science is art. So I think that really, if there was anything I wanted you guys to take away from this, is that there is so much you can do with data. And just because one data analyst does things one way doesn't mean that the other way is wrong. There are so many different ways that you can bring meaning to work. So I think that that is the beautiful part of data. So I would like to switch my screen back to my presentation and say if this is going to work out. Acknowledgements and special thanks. So first off, I would like to thank the University of Chicago Facility Services Campus Planning and Sustainability team, especially Sarah Poppenhagen, Charles Mayer, Alicia Berg, and James Cook. Thank you so much for all you do to support me and teach me every day. I would also like to thank the University of Chicago's Environmental Frontiers Initiative, which I do work with, which is a great way for all of you students who want to get to know how to get involved in how the university is getting students involved in our efforts of sustainability. So if you look on the Chicago Studies page and you want to understand a great way to possibly get involved in sustainability on campus, it would be absolutely awesome. And I got to share my screen again. This is wonderful. Again, Environmental Frontiers, amazing way for you students to get possibly involved with sustainability at UChicago. We are always having fun with new projects on how students are able to get involved with sustainability directly here. So please take a look on the Chicago Studies page that you used to register for this, and you can find a link to the Environmental Frontiers Initiative there. I would also like to thank the Chicago Studies program for allowing me to be here and give this talk for you today to help kick off Earth Week. I would also like to thank Facilities Operations Adam D'Ambrosio for giving me the opportunity to review this data and bring it to you all as well. And I would also like to thank my university mentor back from DePaul, Dr. Teresa Lurs. Thank you for all you've taught me and all the support you've given me over the years as well. So now, Tess, I believe this is where I'm going to bring and pull you back in.
Definitely. Hey.
We are going to open the floor for questions. So Tess.
Yeah, so please feel free to add any questions you have for James in the chat. We thought this could be sort of an interactive back and forth to talk about any of the things we talked about. If it's Environmental Frontiers, if it's this data portal, any questions you might have, please feel free to pop them in the chat. But while maybe people start to think of what their questions are, I was just wanting to ask, well, we have a question here from Chris. I'd love to hear about how facilities makes use of this kind of data. And that was actually my question too. Like, how do you use this in your day-to-day work?
So in day-to-day, there are certain projects that we use and how our buildings stand up against each other. And something like that is exactly that energy use intensity metric. That is something that we use to compare our buildings on an energy use intensity scale within and between each other. So like I was talking about earlier with the idea of labs having a higher energy use intensity than a library, this is something that we use to check our greenhouse gas emissions and commodity usage between buildings as well. It's just a way for us to have a metric that can be accessible to us in such a grand scheme. So I think it's really cool that on top of that, that we use this too, but also so does the city of Chicago.
Mm-hmm.
So
interesting. And then I was wondering if you could talk maybe a bit more about what are some of the sustainability goals on campus? Like how is this data being used to reach these goals, and what are the goals and that sort of thing?
So some of the goals that we have is we are always working to find ways to reduce our emissions here on campus. That is always in the grand scheme, is that we need to know that as a huge institution here in the city, we are I'm not going to say culprit, but we are a contributing factor to greenhouse gas emissions in the city of Chicago. So we have a sustainability plan that we go through every year, which you can find on the sustainability website, which talks about, our percent reduction in emissions that we want to reach by 2025, which I believe is a 25 or 27% emission reduction from a year that we have defined as our target. So this in term with that is one of the things. We are also working with Environmental Frontiers on certain projects like our water usage exactly and other things like that. My coworker Sarah has wonderfully dropped the sustainability website reporting portal where you can look there for some of our direct needs and wants for our sustainability initiatives. So
great. And then I have a question here in the chat. Are there any online sources of information that you recommend about stats and other items you discussed today?
So are we talking about statistics in general, or are we talking about like sustainability?
Hey, James. This is Sarah Copenhagen. That was my question. I was thinking more about stats, like a cheat sheet or, any information for further reading on that, on the stats portion.
So on the stats portion, I would definitely say that you can check. What I would do personally, there are many open Python and R libraries that are very interactive to teach about, stats in that general direction. Sarah, if that's where you're getting at. It's very hard to hear you. So
sorry. Yeah, because you talked about how the algorithms are defined by stats, and that's super interesting. So maybe that's what you were saying, regarding.
Yeah. Okay.
Okay.
So there are, one of the things that I really like about data science and data analysts is that we are a very collaborative group of nerds. So you can check websites like GitHub or Kaggle, or even I have gone on Reddit before and have discussed certain ways on how to learn these, how to learn these ideas of, machine learning and algorithms. And a lot of them can actually be taught if you take the right classes at U Chicago. I know that I have seen that there is a really advanced statistics course that I have looked at, which are Bayesian methods, which is how we test for, multiple hypotheses at once. So it's really a college thing. You can take free courses on udemy.com as well. So, and also Chris has also dropped that shyhacknight.org, which is a really cool place as well, does have talking about using data and publicly found data for good causes as well. So you can check that out as well. Me personally, I like looking at R notebooks and Python notebooks, which are coding languages that are somewhat interactive if you know R or Python, that you can go through and not only use the language while you're learning, but also have that interactive feedback as well.
Great, thank you. And James, thanks for a great presentation. I personally really enjoyed it, and I think you did a great job. really
Thank you.
interesting. So thank you.
Great. And then Chris has another question here. It occurs to me that this is a very rich city-wide data set for large buildings. Obviously, you don't have unlimited free time to play in the data set, but I'd love to hear some of the questions you'd like to explore with it if you had the time.
So I am, again, like I said, a nerd. I would like to actually, if I have the time and the, mental resource of time as well, I just mentioned earlier that Bayesian method of statistics, and that's more of the statistics that I think of because it gets so construed even farther out from that one little equation that we talked about earlier. I would actually want to see if there are any replicatable amounts of data that I could generate based on certain equations that would give us a percent chance of likelihood of seeing one impact that we would introduce as an auxiliary data set, meaning that we would bring in other data like an intervention of greenhouse gas reductions. And if we were to have done that, would it have changed in years prior? And it would also tell me the percent chance of that likely happening in a hypothesis testing situation, meaning that I would look between neighborhoods, between building use type, and also in year. And then I would look at EUI, and then on top of that, let's say, what if we were to cut, our usage of water by 20%? I would create a second data set, bringing that in, and then essentially using a bunch of equations and higher level math and algebra and calculus to create a method and algorithm that would test and train itself over time to give me the best prediction of when or what that would have looked like. So that itself is a lot of work and would take, instead of something like a simple visualization, which can take a couple of days, that would take not only on top of programming that algorithm, but you also have to let that algorithm learn from itself by running and then giving the result, which can take upwards of sometimes to a couple days to, depending on how big the data set is, a week. And these are the reasons they have quantum computing, because if data sets are over 1 million individual rows, it can take a lot of computer power because it's going through so many different types of algorithms and programmed usages to create that prediction. And that's when I said a little bit earlier with that joke where it's like statistics, machine learning, artificial intelligence, because it all goes back to me teaching the computer the original formula that I used to create that algorithm for the outcome that I am looking for. So I would like to know really not the okay, what's going to happen. I want to know the what if, because it's always more, we can always learn from the past, but we can't always replicate the past. But now with advances in math and calculus and statistics and new schools of thought, we actually kind of can, in a sense. Not directly, but we can have a good idea. So.
Interesting. I'm just curious for maybe particular in terms of undergrads that might be interested in getting into data analysis or statistics. Do you have any specific courses or programs that you would recommend them checking out?
Yes. So I would honestly say start with linear algebra. I know that's going to be very scary and it's going to be very daunting, but like I said, that y equals mxb equation is the foundation of 98% of the things you're going to see in data science. So start with linear algebra, then get your way into a early level coding language like Python or R. R is a Python derivative that is actually free and open source, whereas Python is something that is a little bit more closed down and a little bit more syntax heavy. So it's more so two different languages that kind of do the same thing. It's a little bit harder to explain. But from then on, go into discrete mathematics and fundamentals of statistical theory and logic, because a lot of the times you have to sit there and think about what a computer thinks like, which is a series of zeros and ones and ifs and thens. And that's why I think my background of being a cognitive scientist was really something that was able to set me up with success as an analyst, because I knew in the back of my head all these different types of logic and sequential programming that we use in our heads from proven science. But to know that it's not that far off as a computer was really cool and allowed me to hone my skills and understand how this all goes. So I think that's something really fundamental. So.
Great. And then I do want to add, we had a former Data and Dialogue with Nico Marchio from Mansueto that's on the
Yes.
Global Environments website that's been recorded if anyone is interested in doing a short intro to R. It's a good workshop. But and then I have another question in the chat here. James, for internet browsing and social media, do you have an opinion on data collected on individuals and the laws around that in Europe versus the same in the USA? Can it go too far? Privacy concerns? And how do you see this changing in the US, if at all, in the future?
So I am a really big believer in something called the Open Science Initiative. So the Open Science Initiative is really just a really quick way to say, if there is data that concerns humans, it deserves to be publicly available to the point where it's not identifiable down to a subject. But Europe is a little bit of a powerhouse when it comes to data privacy laws. I really like that, you know, let's say you go on like a UK-based or a German-based website, the first thing that pops up on the bottom of the screen is a please do not sell my data or any of that. And there's this really big, you know, not really joke, but kind of a joke in data science right now, which is something called grand theft data, because everywhere you go nowadays, whether you like it or not, there is data being collected on you. So over in Europe, they have a lot of laws that are regulating that. And it's actually starting to see now over in the United States with big firms such as Apple starting to come after Facebook for the usage of data. And there's a huge legal war that's about to go down between that. But I really would prefer people not to sell my data, because there's a lot that can be done with it, as I have shown you here. You know, that point A to point 2, back to point 1 to back to point 3, you know, the possibilities are endless on what you can do with statistics. You know, you can create a linear model that can predict almost anything if you do it the correct way. So, you know, one of the big legal cases that came out in the United States not too long ago was 23andMe and Ancestry.com. They were found giving and selling people's genetic data that was not personalized to them, but that was given to human research institutes such as the Sloan Institute to, you know, work on biomedical, you know, prediction things. And now we have private firms like one here in Chicago named Tempest Labs, who are creating these long patented algorithms that predict human death, and they are used against people every day. So I myself am a very much so like, please use data ethically, meaning that do no harm. So I actually really love that question, because that is something that I don't necessarily get asked very often. So thank you for whoever asked that question.
Yeah, I feel like that's an extremely hot topic in society in general. Is just with increased internet usage, just everything is getting tracked constantly, and it's like, at what point does it have to be stopped? You know, and
at what point do, and that's the thing, is at what point do we say stop?
Mm-hmm.
And you know, you have some people like me who are like, at any point there is potential harm that could come from this in any way, shape, or form. It is a stop. It is a big stop. Mm-hmm. Because I really, you know, I think that, you know, as a scientist myself, and I put data science there as well, is because the part of the idea of the scientific method is to wonderfully take into account the ethics of data. And that is what I really enjoy about this new generation of analysts coming out, is that we are required to take classes on ethics. And I myself did as well. You know, I took an entire 3 courses on not just like HIPAA data, but also like OSHA and all of those other things as well. It's a gauntlet, and there is a lot to consider when going through it. So again, thank you. That was wonderful to hear.
And then we just have one more question in here. It says, what's the best use you've seen made of this data set, being the Energy Star data set?
Energy Star is a very, very well publicly funded, I'm pretty sure if anybody was going to do something wonderful with this data, which they obviously have, I think Energy Star's idea of benchmarking itself in their own open source form like this is gorgeous itself. I mean, really, where are you going to get a computed score based on all of these raw data reported from so many different entities? It is one of the rare cases that we see such a collaborative effort in data together from so many different places. And this isn't just Chicago centric. Energy Star is it's a federal program that we all feed into. So other cities, while I don't know if they make their data publicly available like this, it's out there. And I think that's the coolest part.
Mm-hmm. Cool. And then, sorry, we did just get 2 more, so I'm going to dive into those
All
2.
good.
How do you prevent your data from being used unfairly or for the wrong reasons? And out of curiosity, what does your average day look like?
So how do you prevent your data from being used unfairly or for the wrong reasons? 2 things. 1, you don't always get to, and B, non-disclosure agreements and confidentiality agreements. Those are 2 really the big things on the planet. But any data out there that is publicly available, there isn't much you can do. It's out there. So now, I will say this, is that because I am an analyst, I am very critical of analysis. So if somebody does come out there and post this massive, analysis and expose of data, a lot of the times I have been asked to audit data sets, and on top of that, audit analyses. And you can find an error that will invalidate someone's entire study in just 2 seconds. Because while it is trial and error in the scientific method, there are such things as, different types of errors that can occur from analysis, depending on the type of analysis. So, and what does my day look like? So this actually isn't a big part of what I do here. A lot of I do is I also work with so many different departments, whereas, I wake up, I usually have a couple or 2 meetings on projects that I am working on in their progress. And then I will fine tune some visualizations that I am currently working on for other projects. And then sometimes I will look at other data that is coming in that I am helping manage with other departments and look and see how that is coming in to make sure that further analysis and visualization can be improved on for that as well. And sometimes, because other departments have asked me, I have created surveys to help collect data, because that is something that needs to be done as well when you're a data analyst, is that if you don't have data or someone asks you to get data, you have to go and get it. So, like my day is it's not constant every day. It's not the same thing every day. And I think that's what I really like, is that every day is a new data day. And then other times I get to do cool things like this, where I get to talk to people and explain data in dialogue. So.
Great. And then I just want to give people a last round to ask any other questions. We'll probably start closing up soon. We're getting near the end, but I do love the every day is a new day to day. What a way to look at life.
Yeah, like really.
Nice. So any other last questions from anybody? Feel free to type or just turn on your mic if you're interested in doing that. Great. Well then.
Speak now.
Yeah, exactly. Or forever hold your peace.
Okay.
But great. So this was so wonderful, James. Thank you so much for coming to talk with us. It was great to learn. That's what I love about Data and Dialogues. I learned about these really specific things that I, maybe have heard of remotely before, and to do really deep dive into it is just always fascinating to me. So this was great.
All right.
But I wanted to say, before we end for the evening, I wanted to remind everyone that Chicago Outdoors, which is a new series from Chicago Studies and the Program on the Global Environment, will be hosting an array of events for Earth Week. We have one going on every single day this week, as we showed you the calendar in the beginning. Some of these include the release of a virtual tour of the campus utility plant on the Vermont platform, also the next installment of the Chicago Futures Lecture Series, The Abundant City, which will be a panel discussion on the possible futures for Chicago's food systems, both artistically and agriculturally. We also have a presentation on Monarch Butterfly Community Science Program with the Field Museum. And then lastly, we have a Chicago Cities conversation on the future of urban farming in Chicago. So we hope you guys are able to join us for some of those other programs as well. But this was such a great kickoff, James. And yeah, happy Earth Week, and thank you for joining us.
Happy Earth Week. Thanks for having me.
Thank you,
Thank
James.
you.